In the first part of the video, we have seen how to use function generator with oscilloscope, and we have created one RC circuit for analysis of spectrum, means how to observe the frequency response in proteus. So here we will analyze the same circuit. So for that again we will build the circuit. So take here resistors. Now you know how to take the resistor from Proteus library. Here in this peak part you have to type RES. So it is going to show you the different parts. So here you have to select this RES. If you want capacitor, then you want to have CAP. So here you can pick this generic capacitor over here and click over OK over here. Okay. So already we have taken these two components in our previous section. So I am just going to build the circuit. Okay. So RES, then capacitor here. So these capacitors needs to be rotated. So after right clicking to this, you will be going to get different properties of it. Now you can join the R1 C1. Just it's a simple RC circuit. Okay. So here ground terminal will be available for terminal in terminal mode. In terminal mode you will be going to get the ground terminal. So I am going to ground the one end of C1. So R1 must be provided with some source. So input source. So that input source I can generate from generator mode. I want to provide sine wave. So sine wave, let us take sine wave of frequency. Just join. After double clicking on this icon, you will be able to change the amplitude, frequency of sine wave. So let us take frequency of amplitude of sine wave will be 5 volt. Frequency will be 500 hertz. You can take actually any values. Okay. Now you want to observe the frequency response on of this RC filter. That is nothing but spectrum analysis. That is how much frequency this filter should able to generate, that we want to know. That is nothing but spectrum analysis is nothing but that is frequency analysis of particular circuit. So you want to measure frequency at this point. So to know the circuit that you want to measure the frequency at this point, you need to choose probe over here. So probe, apply the voltage probe over here. Okay. So let us apply voltage probe over here. Here inside this voltage you are going to apply the probe over. There are many probes that have been generated. I will delete and again I will select the one. Okay. Okay. So now here, to have the frequency response in this graph, you can have frequency. So you have to plot a graph over here and you want at this point. So you need to select this and drag it over here. Okay. Now here right click on this frequency response, then edit properties, because we have not provided here reference. So reference is R11. Okay. Okay. And then you need to run this circuit for further analysis. So run the circuit. Okay. So in after running this, you need to simulate the graph. Okay. So if you double click over here, you will be going to get the frequency response. Okay. So this is nothing but the cutoff frequency of this filter. So cutoff frequency of this filter is nothing but you can say is 2K. So we have designed RC filter of cutoff frequency 2K. All of you are getting? So this is nothing but frequency analysis. If you change the values over here, so this is advantage of using such kind of simulation tool. So just by changing those value here, one can get different analysis over here. So here if I change this C1, instead of 1 nanofarad, let us keep this as 1 nanofarad only. We will check, instead of 10k we will have 1k. Okay, so let us see what will be the effect of this. Then simulate the graph. Double click this. So here if you observe, the cutoff frequency of this filter is, let us say, 20k. Getting the point here, 20k. 20 or in between 20 to 50 here, like that, 20k. So in this way, just by changing the value in a simulation mode, one can have analysis of different frequency components. So here in this way one can, that is, instead of building the real time circuits, directly going for building the real time circuits, first of all simulate that by using such kind of simulation tool, so that the efforts can be reduced. That is, first of all, suppose your title is, that is, design a frequency, that is filter of a frequency, let us say 20k. So you need to change, first of all, select R and C, and first of all see using this simulation tool that whether you are going to get perfectly 20k or not, or if you want some slightly changes in your component. Then first of all make sure in a simulation mode that your circuit is good, and then only go for building of that circuit. So that is nothing but the basic advantage of such kind of simulation tools. So in like this you can have, that is, many things that one can do with proteus. Okay, thank you.